posterity.
I'm not sure what to do after that.
Well, the left side didn't work. Let's try the right side, shall we?
Uh-huh.
We got V equals V naught plus AT. We got D equals 1/2 AT squared. We can grant that, right?
Yes.
What's my final velocity for the second part after the engine's kicked off and it comes crashing back down towards zero? So what's my final velocity?
0?
It's 0 after I hit the Earth, but the moment I hit the Earth, it's not 0, right? And the equation changes once I hit the Earth. So I really don't know my velocity when I hit the ground, do I?
No, we do not know
So I'm
that.
going to put a V in for that because I don't know it.
Wait, how come we don't know? I mean, doesn't it at some point like go down to Earth?
It's going to come back down to Earth, but I don't know what it hits the ground with.
Oh, okay.
Right? Now, I could do the problem where, if I knew something about how the ground accelerates it, right, I could do that. But I don't really, do I?
No.
No. All right, so let's try the next piece. V naught, what's the initial velocity for this stretch?
That would be 141.
Oh, 141.
Yeah, right when it's...
Oh, my
never
goodness.
mind. That's when it's
Hold on, that's the final velocity.
So then it would be 141 equals, and then we don't know the V naught.
Okay, hold on. It's going to be negative 141 because it's going down. Do we know the initial velocity for the second part, though?
No.
We do.
We do.
Yeah. The initial velocity for the second part is always the final velocity for the first part, right?
So then that'd be 100.
That would be 100. What's the acceleration?
Ooh, negative 9.8.
9.8. How much time is it falling for?
We're not sure.
We're not sure, but we can solve this, can't we?
Yes. So then...
Uh, 24.6. Is that what you got?
Yeah.
All right, now I have the time. That's interesting. I'm not really sure I needed the time. What else are we going to do?
The displacement one then?
Displacement. Displacement equals 1/2 AT squared plus V naught T. How far is it displaced?
We don't know.
We don't know. 1/2. What's my acceleration?
Negative 9.8.
How much time?
24.6.
What's my initial velocity? Is 100 and 24.6, right? All right. You might be able to solve that, beastie.
Okay. So then that'd be... That'd be negative 505.28
meters. A lot of extra digits there, but that's 5's not ridiculous, so you can live with that. All right. So, what was the question we were trying to solve?
How high goes the rocket when its engine fails?
Okay.
So the is that it? No, that's not it.
That's how high it is. Because that's how far it falls from when it engine kicks out to when it hits the ground, right? That's what we solved for.
Okay. I thought it was gonna be more complicated.
It is, because notice how you started the left side? Did we need any of that left side?
No.
No. So this is a little different, right? A little strange. Makes me a little nervous. All right, you ready to try the next one?
Yes, problem number 8.
Problem number 8. Have you tried it yet?
No, I have not.
Okay, so I'm going to pause the video. I'm going to give you a chance to try it because it's just you and me. So you can take a stab at it before I, just jump on it and start the problem. So let's pause. So you understand that what he's going to try to shoot the arrow through the end of the lasso, right? We're going to try to shoot the. So we have to figure out what time he has to launch his arrow so that it goes through the lasso because he can't see the Lone Ranger in the bottom. You can only hear him grunt when he throws the thing up in the air. So how are we going to figure out what time he has to shoot the arrow? What can you tell me about
that? I'm not sure.
All right. Well, can you tell me how long it takes the arrow to get to the well?
It takes. Well, it doesn't say how long it takes, but it travels at 30 meters per second.
And it's going 40 meters, right? So what equation will we use?
Displacement one.
Let's try that out. Let's see if it works for us. How far is it going?
40 meters.
40 meters. What's the acceleration?
We do not know.
We do know.
The negative 9.8.
No, although that is a really good guess. I feel bad. I feel dirty saying that's wrong. It's going sideways, isn't it?
Yes.
Is it anything slowing it down or speeding it up?
No.
Then the acceleration is 0. Now again, there's a reason
zero.
why this is the really hard problem, because that is one of the things that's going to trip people. Because they're going to want to put an acceleration there, and there's none that goes there. Okay, what's the initial velocity?
The initial velocity is 30 meters.
Give me a second. And then time I don't know, right?
Yes.
So that in my calculator, I'm going to get a time.
So that's gonna be I'm not getting anything.
Oh, what happened?
Well, I'm doing the
That cancels out. So 40 divided by 30.
Oh yeah. Oh my god, I keep forgetting.
Nah.
So then 1.33.
I like it. So that's how much time it takes to do that, right?
Yes.
All right.
Yes.
You want to know what time you have to release the arrow so it hits the lasso. What else do we have to know then?
Where the lasso gets to.
We know where it gets to. We know it's going to get to 1 meter above the well, right? We don't need to know where. What do we need to know?
Oh, what time?
What time? So how are we going to figure that out?
So then that would be. Should we try displacement as well?
Now, how far is the lasso going to go?
It's gonna go. Well. He throws it up.
Okay.
And then it travels but strikes a crossbow at 2 meters.
Right, but he throws it from a 25-meter deep well, and Tonto's aiming for it, so it's 1 meter above the well.
Wait, how is it 1 meter above the well?
Well, the well is here, right? There's a crossbar 2 meters above the well. He's going to try to hit it in between, right? Just 1 meter above the top of the well. It says the well is 25 meters deep.
So then 41 meters?
41.
Don't you add both of
Well,
those?
aren't we going to add the 25 to the one, are we? The well is 25 meters deep, not 40 meters deep.
Okay.
Does that make sense?
Yes.
Okay,
Yes.
so we got 26 meters here, 1/2. What's the acceleration of a lasso being thrown upwards once it's been released?
We don't. Wait. Negative? No. 9.8? Yeah, right.
Yeah.
Right.
Lassos are like everything else; they're going to fall. Although initially it's going to go up a ways. How much time is it going up?
We don't know.
Its initial velocity he throws it at?
25.
Times. We don't know, but we can solve this, can't we?
Yes.
Oops.
Okay. It's gonna be. I got 3.6 and 3.45.
I got 1.45 for the second one.
Oh yeah, 1.45. Sorry.
Right.
1.45. Sorry.
Now, your worst nightmare. 2 positive answers. What are we going to do? Now, I got to think about which one of these answers makes more sense.
Sorry. Would that be 3.6?
So I throw this lasso up in the air. Why do I have to hit it 1 meter above the ground? Why can't I just hit it someplace really high?
I'm not sure.
All right, let me ask a different question. Why does this have 2 times?
Because the calculator thinks that it's doing it again, twice.
Well, if you throw something up in the air, doesn't it pass the same height twice?
Oh yeah.
Right. So which one of these should I pick?
The first time that it passes through.
So the first time because it's going to hit the crossbar, right? It's a crossbar, my acceleration is going to get confused. I'm never going to get to 3.65, right? It's not going to go way up high and then come back down, right? So 1.45 seconds is the time?
Yes.
All right. So that's how long it takes to throw it up. This is how long it takes to shoot. How long should Tonto wait for the moment he hears the grunt before he releases the arrow?
You should wait 1.45 seconds.
If he waits 1.45, then the arrow is going to take 1.33 seconds to go. The lasso will hit the top and fall back down. You'll never get there. All right? So it takes 1.45 seconds to throw it up there. He knows once he releases the arrow, it's going to take 1.33 seconds to get to the well. So how much time after the Lone Ranger throws the lasso up does he need to release the arrow?
Is that where? Then I'm not sure.
Okay, so if he it takes 1.33 seconds to get there, correct? Okay. How long does it take lasso to get there?
It's gonna take 1.33.
No, it takes how long for the... If Tonto releases the arrow, okay, at the same time, it'd get there 0.12 seconds too early, wouldn't it? So if he waits 0.12 seconds, wouldn't he be just perfect?
Yes.
That's the answer.